Hello and welcome back to California Geology. Today I want to talk about the Miocene extension and rotation of the transverse ranges and the development of the California borderland. Before we look at figure 16-26, during late Mesozoic and early Cenozoic time, sedimentary rocks are actually absent in central LA Basin. They're also absent in the offshore Santa Monica Basin, and they're absent in the San Pedro Basin and Catalina Basins. So anyways, in fact, we're looking at, these are really before Miocene time. So in other words, like for example, the Matalija sandstone, the Eocene sandstones and the cold water sandstones, the cozy dell formations that expose up in the Santa Barbara region, up in the Santa Ynez Mountains, we don't find those rocks in these basins in Los Angeles and offshore Los Angeles in the California borderland down here. Now, why would that be the case? It's probably that during that time, before Miocene time, those basins had not existed. So let's look at this figure on page 445. And we see that in this central LA basin region, south of the Santa Monica Fault, there are no early Cenozoic rocks in this region here. And then also offshore, so once we go off of San Pedro here, we find that the Santa Monica Basin also does not have, and also this Catalina Basin, there are no rocks of early Cenozoic or even late Cretaceous age, which means that these basins probably didn't develop until that Miocene time. So this, here they'll talk about that Miocene extension and rotation. So another, they start off the section with late Mesozoic and early Cenozoic sedimentary rocks are absent in Los Angeles Basin east of that Newport Inglewood Fault, and also in these basins that are offshore. So one thing we do find, in fact, we look over here, during this late Mesozoic and Cenozoic time, is that the Miocene sediments directly overlie this metamorphic rock called the Catalina Schist. And the Catalina Schist is exposed at Point San Pedro in the LA area, and also on Catalina Island. And this Catalina Schist, the age, well, there's some kind of controversy. In fact, there's been some ages as young as 5 million years, because it's pretty young. But also the Catalina Schist contains blue schist minerals, which indicate that it's been in a subduction zone. It's gone down 20 to 45 kilometers depth. So the only time there was subduction here in California was obviously during the Mesozoic time and then in the early Cenozoic time. So what the Catalina Schist, it may be a metamorphosed Franciscan formation. In other words, in fact, most of the Franciscan is already metamorphosed to green schist and blue schist facies. However, these rocks seem to be re-metamorphosed or affected by another metamorphism that occurred about 5 million years ago. And that was probably shearing related to this Miocene extension, this opening of this California borderland and developing of these basins offshore California in this region here. Now, what's the evidence that we have? So the evidence that we have is that the basins did not exist in these areas until Miocene time. Is one is that we don't see the sediment. We don't see that early Cenozoic sediment. That's one of them. I'm going to show you an animation here in a moment that shows these basins being formed. And the other one is the Santa Monica Mountains and the parts of the transverse ranges have a number of volcanic rocks. There were volcanoes, and they erupted pillow lava. And so those are the pillow basalts you find in the Conejo volcanics, and they're also Miocene age. So this is a little cartoon showing here the Sespe Formation, Vaquero sandstones, which is actually now marine. And then here we see older rocks like the Matalija sandstones up in the Santa Ynez Mountains. But then we start seeing this extension, right? So you start stretching this out, opening this up, and this allows magma to upwell from the mantle, producing these volcanoes. Those would be the Conejo volcanics. And we see that they form these distinctive pillow structures. This is figure 1623 in your book. And these pillow lavas indicate that erupted underwater. So nice pillow lavas here for these Conejo volcanics. Now, The third piece of evidence is that there are these rocks, the Poway Conglomerate. They're best exposed over in the Poway region, which is in San Diego County, over by Escondido, east of Vista, California there. And then and these conglomerate rocks indicate that they're eroding. They're mostly composed of volcanic clasts and some metamorphic rock, very distinctive when you see the conglomerate. And then there's also paleomagnetic evidence indicating that there's been a 90-degree rotation of this transverse ranges. Now, this conglomerate, we also find conglomerate on the Channel Islands, and we find it in the transverse ranges. So how can conglomerate from San Diego, from Poway, be up here in the Santa Barbara region in the Channel Islands? And it has to do with this Miocene extension. So if we look at this animation here, let's just run this, and we're going from about 20 million years toward the present. You can see there the Santa Barbara block is rotating right there. It's rotating, and the key thing I want you to notice here is these gray areas, which are going to eventually become the California borderland. That's the area that's experiencing that shearing or that extension, right? That extension. And then here about 4 million years ago, the San Andreas Fault runs onshore here, and then we see these great basins of extension in here, right? So let's look at the Poway Conglomerate here. And so in this animation, we're going to see the Convergent Margin. So here we have the trench here with the teeth. So this would be the Farallon plate that's subducting under North America. And these would be the arc volcanoes. And so these volcanoes, eventually you're going to see erosion and formation of submarine fan deposits, conglomerates, turbidites. And then the faulting is going to break those things up and bring some of those units over here to the transverse ranges. So here we see the subduction of the Farallon plate along the trench. And then there's the eruption of the volcanoes here on the North American plate. And then we're going to see erosion during Eocene time. So there are the conglomerates coming down. They're volcanic clasts into these submarine fans, turbidity currents. And now faulting is going to break all these up, cause a Miocene extension there, rotation of the transverse ranges. And now those rocks are exposed not only up here in the Poway region, this is the Poway Conglomerate, but also on the Channel Islands and regions up here in the transverse ranges. Now, there was another one I wanted to show here on the rotation of the transverse ranges. So there is a Conejo Volcanics eruption during Miocene time, and then this green area represents the Catalina Schist. So see the schist is being pushed up, and so now we're going to expose that schist, bring that schist up to the surface here, and we're going to get these Miocene rocks that are going to occur after this extension. They're going to be deposited directly on this Catalina Schist. So the Catalina Schist is the older rock that is probably the Franciscan equivalent of that. So if we look over here at our book again, there's an interesting figure on page 446, which shows a cross section across from basically Catalina Island over towards San Pedro over here, and showing the Santa Monica Basin. So these wiggly lines over here represent the Catalina Schist. This is the Catalina Schist. And then these volcanics, those are the volcanoes of the Conejo Volcanics. Here's some more Conejo Volcanics over here. And then we're seeing this extension. We're exposing the Catalina Schist here due to this extension. So in fact, it's called a detachment fault. So very similar to what we see in when we form the turtlebacks in the basin and range over in Death Valley. We're seeing quite a bit of extension here and rotation. And so you can see this block is sliding this way, this is moving that way. We're seeing unloading, so the crust moves up. And the other formation I want to point out here, these stipple patterns represent the San Onofre Conglomerate. And the San Onofre Conglomerate is also Miocene in age, and it's one of the first sediments that were deposited on top of this Catalina Schist. So there it is. It's an interesting scenario, how we develop the California borderland and these Miocene basins. And then we have paleomagnetic evidence and the rocks actually that tell us there's been quite a bit of crustal extension in this region here. Well, let's stop here for now.